that in the practical, we are measuring basically readings in what is called in triplicates. Triplicate means you just repeat basically the same measurement 3 times. So you have a measurement 1, measurement 2, measurement 3. And what we do, the reason why we do that is actually we go back to the picture that I just showed you. Okay, good. That's interesting, but nevertheless. In this picture, I showed you the difference between accuracy and precision. Now, by repeating this experiment 3 times, we get 3 measurement points. In this case here, in the picture, they did it in quadruples, so 4 measurements. So here there are all these, is it 4? Yeah, it's 4. All these measurements are close together. Yeah? So these 4 measurements, in this case here, are very close. We would hope that these M1, M2, M3 are also very close together. If you are precise, then the measurements are close together. Does that make sense? Yeah? The more precise you are, the closer the measurements are together. We also call this the measurement of dispersion. How dispersed are our data actually? The less dispersed, the more precise they are. And the more precise, the better your data are. Yeah? That's why you want to repeat experiments to see, am I getting everything all over the place, or how precise is it actually? So that's the measure of dispersion. Now, how accurate is it? How accurate is our measurement? Remember, accurate means how close is it to the real value? So accurate, how close to real value? And this is something that's not terribly easy to do in this case. Of course, what we could do is we could ask our technical services to do this experiment for us so that they give us actually an accurate reading for these 3 points. Yeah? We have tried that in the past. We have asked demonstrators to repeat this experiment and do the accurate reading. We've done that with the technical services. I've done that with some of my colleagues, academic colleagues. Yeah, the results were quite interesting. I have to say, occasionally I believe you guys more than I believe technical services, but I don't want to say that in public. So, you know, I will, if you ever quote me on that, I will deny any knowledge and say that you are lying. Right? So how could we find out this, what the accurate number is? There's a trick. And I come back to that trick in a couple of minutes, okay? So bear with me. What we want to do is we want also to give a sort of a representation of the data. As I said, we want to see how precise the data are, and we want to, in a way, describe the data. And the easiest way to describe a set of data is with statistics. It's called descriptive statistics. Descriptive statistics. In contrast to what we are going to do soonish, it's called inferential statistics. But let's start with the descriptive statistics. We obviously are quite happy that usually when we do measurements, there is some kind of uncertainty in it. That is where statistics comes into it. So, for example, I do measurements M1, M2, M3. And I want to summarize that. The easiest way to do that, and you've done that before, I know that because my son, who is currently in year 8, he's doing that, is the mean or the average. I assume you all heard about that, yeah? So, mean. Usually this is abbreviated as an X with a line on top. That's the mean. So, if we've got 1.0, 1.2, 1.4, what's the mean? 1.2. How do you do the mean? Well, you add everything up, and then you divide by the number of measurements that you did. Right? Very easy. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. What's the mean? Loud? 5? So, let's do a little trick. 1 and 9 is 10. 20, 30, 40, 45 divided by 9, the mean is 5. Yeah? Easy. Totally easy. One problem with the mean. Can you see a problem with the mean? Which is? If you have exactly, say loud. Yes, if you had something completely ridiculous, like in this case, 165, yeah, you very clearly know that probably there's something not right. What's the mean of that? Well, I've done that before. I think it's 21.67 or something like that. What did you get? 22.3. I believe you. 22.3. Yeah? And everybody would see that, hang on, that can't be right. So the mean is extremely sensitive sensitive to extreme data, outliers, anomalies. I can't spell anomalies. So to extreme data. Okay? Can we use something different that is not so sensitive? Standard deviation? Ah, that's interesting. We'll come back to that. There was... Sorry? Loud? Loud? Median. Yes. What is the median? Sorry? It is 1, 2, 3, 4, 5, 6, 7, 8, 9. It is the middle, the most middle number. Yeah? So in this case here, 1, which number is in the middle? 2, 3, this here is the median. Yeah? Is this median sensitive to any outlier, to any extreme data? Does does this 165 affect the median? No. So the median is very useful if you've got really weird numbers, because the median is not affected by extreme data. Yeah? Hey, how cool is that? In our example here, the median is the same as the mean, but it doesn't have to be. Yeah? Are you happy with that? What would happen, actually, if we had something like that? Oops. Can't get it right here. Yeah. Obviously, I don't ask you to calculate the mean. It's 5.5. That is a very, very good suggestion. Because before, we had an odd number of numbers, 1 to 9, or 1 to 8, and then 165. So we could easily pick out the median number, the most middle number. But in this case, we have an even number, and you are absolutely right. So we do